Hello, I'm Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about the features for a set of parallel resistors on the topic of equivalent resistance of a set of resistors connected in parallel in a circuit. We talked about this in our previous episode in detail, so go and watch that episode as a refresher before you view this one. So now we can begin discussing about the features of these for a set of parallel resistors. Okay, our first feature. In this circuit diagram, if you can see very carefully, the potential difference across the ends A and B, the common endpoints A and B, is V. That is the potential difference of the source. And also in this circuit diagram, the potential difference across RP is also V, which is the potential difference of the source. So here across AB it's V, and also across RP it's V. And the most important thing is, here the potential difference for each of the resistors is same. For resistors with resistances R1, R2, and R3. Now moving on to our second feature. In our second feature here, the total electric current gets split into these resistors with, like if I consider this one as I, then I'm considering the electric current through R1 as I1, here as I2, and maybe here as I3. So this is how it got split. The total electric current got split into these three resistors. But in the case of this diagram, it's very simple. Total electric current I flows through the resistor with resistance RP. Now that we've discussed about all the features, we can draw a conclusion out of this. That is that I, the total electric current, is equal to I1 plus I2 plus I3. Because anyway, this electric current got split here, so if you bring the split parts together, it should give you the total, isn't it? Hence, this is our conclusion. I equal to I1 plus I2 plus I3. Now, if we want to go further, we have to get something else. Now, if you can recall from Ohm's law, V equal to I into R. Now, if you want to find the potential difference across RP, then it will be V equal to I into RP for the potential difference across RP. This is for this circuit diagram. Now, if you want to take in perspective of this circuit diagram and find the potential difference for each of the resistors, then anyway, the potential difference for each of the resistors is equal. It's just that we have considered differently, so we have to think like that. Like V equal to, for R1, it's I1 into R1, since I is I1 in this case, because it's going through a resistor with resistance R1. I1 into R1. Similarly, it's equal to I2 into R2. And finally, that's equal to I3 into R3. And this is for across AB. Now, using this information, we can go further in this equation. Now, here we can get I equal to V by RP. V by RP equal to. Now we can get for each of these values, I1, I2, and I3. Like for I1, we can get V by I1. V by R1. I'm really sorry. V by R1. Plus, similarly, V by R2 plus V by R3. Now, it's very simple. Just take V, that is the potential difference, as common in this side of the equation. We are just one step away to getting our conclusion. And now we can cancel this v, and ultimately we can get our ultimate conclusion has to be written after I erase the board due to lack of space. So our ultimate conclusion is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. And this is our final conclusion. So I'm giving you a few moments to look at the board so that you can clear your concept. Hope you enjoyed learning with me, and please like, share, and subscribe my channel, and stay tuned for new episodes. Thank you.